Welcome to Cut the Crop, keeping you in the know about everything you grow. Researchers, growers and other interesting folk delivering insights and information on topics ranging from agronomy to profitability. Brought to you by the Foundation for Arable Research.
Hello and welcome. I'm Alison Stewart, your host of Cut the Crop. And today we're talking to Sarah Mansfield from AgResearch. And we're going to focus on a very common and problematic insect pest, grass grub. And so welcome, Sarah. Thank you for coming today. So before we go into talking about the current research that's going on, I guess for a recap for a lot of growers, just talk us through the life cycle of grass grub and, what it's doing and how it impacts on our cropping system.
Very well. First, thank you for the opportunity to talk to the farmers today, especially about grass grub. So grass grub is unique to New Zealand. It's an endemic beetle, not found anywhere else, and it has colonised many of our introduced crops like pastures, arable crops, things like that. And the way it damages the crops is the grubs live underground and they feed on roots. So if you're talking about arable crops, particularly if they're sown in autumn, what the grubs like to do is they feed on the young developing seedlings. And what makes them really fun is they're quite good at lining up on your seedling rows. So you can actually see where a grub has worked its way down the line of seeds because there'll be a whole lot of seedlings tipped over. And that means one grub's just gone down going shung, 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 taking them all out. So in terms of the life cycle, they have only one generation per year. The adults in Canterbury come out actually apparently typically around about Guy Fawkes Day in Canterbury. It's a bit earlier as you go further north because grass grub occurs throughout the country and a bit later further south. The adults come out and they mate and they lay their eggs. So they're laying their eggs kind of in the early to late summer period, and the larvae are developing through from late summer, early autumn, and potentially going into winter, depending on how much food they've had.
So weather conditions that make them worse?
Yeah, there's with them having only one generation per year, they're not like it's not like they'll speed up their generations if the weather is warm. But dry weather conditions during the egg laying and the early larval stage is quite damaging. They don't like very dry conditions at that point. The other issue is the amount of food they have available to them as a grub, depending on whether the crop is irrigated. If the crop is irrigated and the moisture is nice and there's lots of food, they'll stay nice and healthy and keep growing and feeding quite quickly. And then when they've completed their feeding, they actually overwinter as a late stage larva and then pupate to come out, back in the spring. But if you're dealing with drier conditions going in the autumn, say if it's not an irrigated crop, it's a dry land, then you can see spread in the development. So you might see a mix of smaller ones and bigger ones, just depending on who got the most food. So the ones that get more food, they'll keep going a bit faster. But if they're in a dry patch of the paddock and there's not much to feed, they'll hang out there. And if food appears later, when you sow your autumn crop or conditions improve, they'll start feeding again.
So what other sort of risk factors are there? I mean, we know the weather conditions can drive it. Are there management practices that can make it worse or make it better?
Yeah, so there's definitely an interaction between what's happened the previous year in terms of what was the crop in your paddock before and what it is going to be, this autumn. So, for example, if you've had a rotation that was favourable to grass grub the previous year, maybe it was a pasture that you've decided to convert to a crop, or maybe it was something like a clover seed crop, which they find really tasty and nutritious and do well on, then you're more likely to have a problem the following year. And this is partly because the female grass grub, when they emerge and after they've mated, they lay their eggs near where they first emerge. So if you've had grass grub in a paddock that's the previous season, you're going to get it the next season because all the females that emerge are going to lay their eggs there. So there's always a carryover. If you do go through a full cultivation before you sow your next crop, that does help to knock the grass grub out. Because as you can imagine, running the cultivation through, it'll physically kill some of the grubs because they'll get chopped up, but it also encourages birds to come in and feed on the exposed grubs that have been brought to the surface. So if you're lucky, you can get some extra bird activity to help control. But if you're going with a no-till, if you're trying to direct drill, then you're not getting that management happening. And so again, you're at greater risk that there'll be grubs carrying over from the previous season and causing damage to your crop.
So what kind of numbers of grubs, are we talking about? What's like the threshold to create sort of economic damage?
Right. So the threshold, of course, depends on what you're planting and what your crop is. But if we're thinking about your typical autumn cereals, the way you count grass grub is you take a spade and you go out and dig what we call a spade square. So you just use your spade to kind of dig a square area of soil over and sort through it. If you're getting the equivalent of about 2 grubs per spade, and if you want to convert it to an approximate number per metre squared, you multiply that number by 30. But 2 grubs per spade is going to be damaging for cereals. That's the threshold for damage. And you can actually get, if you're unlucky, you can get 3, 4, even 5 or more per spade. And if you're in the 5 or more per spade, then you're looking at really serious damage. One different point to consider if you're growing some of the other seed crops, cereals have a slightly higher sowing rate. And as the crop develops, if the weather is good, they will also tiller. So they can compensate to some extent for damage. But if you're growing something like a carrot seed crop that has a lower sowing rate, so you're putting in fewer seeds per area, and they're not going to naturally tiller or compensate. So ideally, if you've got the time, go out with a spade and do a bit of digging in your paddock. Try and do about 20 spade squares spread across the paddock and have a look at what your numbers are, because grass grub's quite patchy. So you might find patches that are much higher and patches that are lower. They won't necessarily be nice and even across your paddock.
And I guess, a lot of people are very familiar with grass grub because we get it in our lawns, in our gardens as well.
Absolutely.
Yeah. So let's talk about control measures and management strategies. What's the best thing that the growers can be doing at this moment?
So, the first thing would be actually, if you do go out and check to have a look, think about your paddock's history and what you're doing. And in terms of what you can do for control at sowing, assuming you are going to have a problem, you're looking essentially at applying insecticide treatments at sowing. And your 2 major options are either to apply coated seed that contains that's coated with a neonicotinoid insecticide, and that will help protect your seedlings. Or the other option is you actually drill a granule at the same time as you drill the seed, and that's where you're putting in things like diazinon or suscon green as a granule. And again, either of those things are happening at sowing, and those are essentially the options that you have.
And how effective are those options? I mean, those insecticides, they work well?
They do, yeah. They are effective. The challenge is that from an environmental perspective, they're falling out of favour. And of course, diazinon is going to be deregistered completely in New Zealand from 2028. That's part of the class of organophosphate insecticides, and there are significant environmental and human health concerns around them, and these products are being withdrawn. And I imagine many of the listeners might have heard, of course, that in Europe there's controversy around the use of neonicotinoids as well. At this stage, that's not affecting our use in New Zealand, but it's something we have to be aware of because it's a potential impact on our markets. If our consumer markets say they don't want products with that, it doesn't really matter whether it's allowed in here. If people won't buy it, you've got a problem.
Yeah. So what are we doing to try and develop new options? I mean, AgResearch and FAR are involved in a joint project. Do you want to tell the listeners about that?
Sure. So we're working with FAR it's our second Sustainable Farming Fund project around grass grub, and the current one is looking at testing a new biological active that's isolated from here within New Zealand, so it's locally grown, so to speak, and this would be applied in a similar manner to the granules that people currently apply, like diazinon or suscon green. So it would go in at sowing, and when the grub eats the granule, the biological takes it out and gives it a really severe stomachache, so it stops feeding and then kills it after a few days. And so what we're doing in the project is trying to confirm the efficacy, test the efficacy under field conditions and get an idea of how best to use it. And the intention is to work with a third party, a commercial partner, and hopefully register this new biological active. So might be a little while yet before this is on the shelves and available to farmers, but that's what we're trying to do, is to develop an alternative that's environmentally friendly.
And when you're talking about a biological, you're talking about like a living microorganism, a bacterium?
Yes, it's a bacterium. Yeah. So some of you might be familiar with Serratia entomophila, which has been marketed under various names and now is on sale as BioShield. So this is another bacterium that's related to that, but it acts a bit faster. The Serratia entomophila is great in something like a perennial crop like a pasture, particularly ones that can tolerate more damage because the threshold for grass grub damage is higher in pasture. But in your arable crops, you need the insect knocked out pretty quick because once it's chewed on your seed, it's done the damage. Even if you kill it afterwards, it's a bit late. So, yeah, this active has a slightly faster mode of action, which we hope is going to be more equivalent to the kind of protection farmers see from insecticides.
And being a biological, is it, I mean, from the farmer's perspective, is it going to be different for them to be able to use it, or their expectations around how it works? Because biologicals, sort of, it sounds great, but often they don't necessarily perform in the same sort of knockdown way that chemicals do. So is there education and awareness around how to use a biological most effectively?
Yes, that's the other aspect of the project. Since, of course, this biological is not yet on the market, we can't talk too specifically about that, but we are trying to engage with farmers and to get an understanding of their feelings and attitudes or willingness to use biologicals. Because, of course, everyone has different levels of willingness to adopt new things, and to understand what people's concerns are so that we can best address that and try and give people confidence when the product is on the market. Because as I said, it does have a mode of action that if used correctly, it will be close. It should provide similar efficacy to the insecticides. That's what we're aiming for. But it will potentially require perhaps some slightly different handling when it comes to getting it out to the farmers, but we are aiming for a formulation that will behave and be applied in a similar manner to, and using similar tools to what farmers already use.
And what we really hope is that, that this product and any other new products, we manage to get them out available to growers before we lose some of the existing products.
That is definitely, really what we need to do, because there's always going to be a transition period. Developing biologicals for something that's unique to New Zealand is quite challenging because, we have to develop the capacity to manufacture the volumes and what is needed here in country, and that's proved challenging in the past for other products, as well as, of course, achieving the formal registration. And one of the challenges in getting the data for formal registration is we only get one shot a year. There's only one generation of grass grub per year, so you've only got one window to get your data. So that means it takes a bit longer to gather that data than it might do for something that has many generations per year.
Okay, great. So take-home messages for the growers then around grass grub. Anything that they should be specifically thinking about in the next month or so?
You need to be thinking about what you're planting and what your control method is going to be. What's the history of the paddocks that you're turning over? Are you going to cultivate, or are you going for a no-till? Because no-till will increase your risk. It doesn't make it unmanageable, but it does increase it. What was the past paddock history? Does that increase your risk? And again, are you working with irrigated or dry land? And what have the conditions been on your local farm in terms of the likely feeding of the insect? If you've got that mix of age, because it's not been the most favourable, you could see extended feeding going into winter, which might mean even late sown crops, as late as May, could be impacted by grass grub. Whereas if you're irrigated, then they're probably going to be nice and fat and happy. Some of the healthiest grass grub I've seen have come out of irrigated pastures.
Unfortunately.
Unfortunate for the farmer. We were wanting them for an experiment, so it was ideal for us, but really not good for the farmer in that scenario. All of those things to think about, and remember that if you are going to apply control, you actually have to do it at sowing. It's no good waiting and seeing the damage because there's nothing you can do at this point. So that's what I would recommend.
Excellent. Thank you very much, Sarah. And thank you very much, listeners. Have a great day on the farm.
Thanks for tuning in to Cut the Crop, presented to you by FAR. If you'd like to know more about any of the topics discussed or have any suggestions for future topics, go to www.cutthecrop.co.nz.